Today we've got Jaramar Villarreal Rosas going to talk about her PhD. She's just submitted her PhD, where she worked on ecosystem services and understanding or spatial planning around ecosystem services and how that affects multiple beneficiaries and equity. So some really fascinating work from Jaramar, and I think she's going to tell us all about the stuff she did and present that to you today. So welcome, Jaramar. I'll give you the seat. And,
Thank you. Get closer. Thank you, Jonathan. Okay, so everyone can hear me well, right? Okay, well, thank you so much for coming today. Yes, I will be giving an overview of my PhD thesis called Managing Ecosystem Services for Multiple Beneficiaries. So I would like to start by providing a little bit of background about why I got interested in the topic of ecosystem services. So when I was doing my master's degree a few years ago, I investigated how environmental degradation affected the livelihoods of these the Kukapa indigenous communities. The Kukapa people also call themselves the river people because their territory expands all along the Colorado River Delta. And it was quite interesting and a bit sad as well to understand a bit more about how environmental decisions not made by the Kukapa people, but made by other people affected the riparian ecosystem. And then how, as a consequence, Kukapa people had to come up with new economic activities and change the relationship with the river. So really, the point that I want to make here is how different people have different values over nature and different ways that they use or value nature, and that then ends in making different decisions that can affect different people in different ways. So I had this question in my head: how could we make more sound decisions that can account for the different ways in which people value or interact with nature? So ecosystem services it's this concept that kind of integrates this. It's a way of connecting how people obtain benefits from nature. So I want to, maybe a lot of us are familiar with this concept, but I want to break it down a little bit into how actually that happens, how people obtain benefits from nature. So first we have the natural capital, or all these processes happening in ecosystems that potentially provide benefits to people. But we also need the demand side. So that refers to if people value or use nature in some way. But to then link these two, we need what we call the flow, which is could be human-driven or different biophysical processes that connect natural capital to demand. And this is how then we can obtain benefits from nature. So in this simple example of food provisioning, and the benefit is nutritional value or for people to have a healthy life. And the other important thing here is that without any of these components, either the biophysical supply, flow, or demand, we won't get any benefit. But as I was saying before, there are different ways in which people interact with nature. So, for example, in the water that this lake provides, so there may be some people that value the fish living there. There may be other people that value the water and that they use to grow the crops. Or there may be other people that value it more for recreational purposes. So all these different values that people have over nature are important. And when making management decisions, we should consider them. So if we want to protect or secure these benefits from management, then it's important to understand how these different components of ecosystem services that I talked about before and how they're different for different people interact. And it's important to understand these different interactions for different people, because otherwise our decisions can then lead to social inequalities, providing disproportionate benefits to some other people, or even creating negative impacts to some. So with these ideas in my head, and my overarching aim in my PhD was to develop and evaluate management strategies to incorporate multiple beneficiaries of ecosystem services in decision-making processes. So my thesis structure, and which is also the structure that will follow the rest of this presentation. First, I'm going to talk about the gaps in spatial planning for ecosystem services. Then in chapter 2 and 3, I use the Brigalow Belt in Australia as a case study. One chapter to analyze forest loss impacting different people, and another chapter looking at the trade-offs when making decisions between efficiency and equity. And I have another case study in Nepal, looking at the trade-offs between efficiency and providing benefit at different spatial scale. And I will finish with some main messages from my work. So this is my first chapter. And if you want to read a bit more detail about it, you can have a look at the publication. So advancing systematic conservation planning for ecosystem services. So for the ones that are not very familiar with what systematic conservation planning is, I've been talking before about making decisions. So systematic conservation planning is just a structured way of making decisions, where we explicitly establish what are our management objectives, the actions that would lead us to achieve those objectives, the constraints or the limitations to achieve them. And we integrate all that in the model and then in a special explicit way, where we can then, based on the limitations and our objectives, identify where in the landscape we should apply those actions to achieve our objectives to make it more efficient. And so systematic conservation planning has been widely used for biodiversity and a little bit for ecosystem services, but not as much. So for my first chapter, I had this question. So to what extent the different components of ecosystem services that relate to benefit are considered in systematic conservation planning applications? So to what extent the flow chain that I talked about before has been considered? To give answer to this question, I did systematic literature review, where I identify a total of 90 papers that use systematic conservation planning to solve a management problem and identify ecosystem services. So a total of 326 ecosystem services were the ones that I analyzed. And these are the main results. So basically, most of the existing services were just assessed considering the supply, which I just represented here with a tree. And then in really few of them consider the supply, the demand for different beneficiaries, and the flow, which I represented here by two groups of people. So what are the implications of this? So if we just consider supply and we ignore the other components, as most papers have done, we have a high risk of selecting areas that can provide benefit when making our decisions. So I'm gonna try to explain this a bit more. So say this green grid is a forest, and the yellow squares are our decision units. So And we have this ecosystem service or recreational service. And we, this group of people or this person only has access to recreational services in this particular area in our landscape. If we ignore this information, we can end up selecting areas that are not accessible for this group. And if our decision was to conserve and the rest to be turned into agriculture or any other land use, potentially that service will be lost, and then people will be sad. And that could mean the same for different groups of people. So if we consider that variation across the space and beneficiaries from different groups when making our decisions, and we are aware of where people have access to the benefits they expect, then we can make changes in how we make those decisions. And instead of selecting these areas, we can probably select areas where people can actually get the benefit. So the main messages then from my first chapter is that we need our management objectives need to be beneficiary based. And that means just considering the benefit that people would obtain from our decisions. And for that, it's important to identify the different components that relate to benefit. Now, I'm going to talk about my chapter 2. In this one, I analyzed how forest loss has affected flood protection for different beneficiaries. So this map, maybe some of you are familiar with it, from Evans in 2016. So this map in red represents the deforestation from 1972 to 2013, human-driven deforestation. So most of it has occurred in Queensland, and for the more local ones, you may know that this area is actually the Brigalow Belt. So the Brigalow Belt is called after the tree Brigalow, which there's a photo of the Brigalow here. And now it only has less than 10% of the original extent. Well, for my study, I focus on these two different time periods. So the deforestation from 2002 to 2015. And as you can see, this deforestation, land turned into grassland. So we lost forest for grassland. In this area as well, the Brigalow Belt, it's usually impacted by flood events. Maybe some of you remember the 2019 flood events that cost more than $6 billion in repairs, affecting different sectors from urban residents, the food production sector, and other communities. So then in this chapter, my question was how forest loss impacts multiple beneficiaries of flood protection. So what I did to analyze this, I made a temporal and spatial assessment of flood protection. So I started by identifying the infrastructure at risk of flooding for these 3 different beneficiaries. Then I used INVEST for modeling software to identify or to delineate the watershed that will drain to where there's this infrastructure at risk. And again, using INVEST, I then modeled as well to what extent after a rain event, water flowed in the landscape. So this is quick flow, so the water that flows in the landscape after a rain event. And then I estimated how the quick flow changed when we had forest and when we didn't have forest. So I made this assessment for these 2 different time periods for the 3 beneficiaries. And these are the main results. So overall, considering the whole Brigalow belt, we have a decline in flood protection and affecting mostly the urban residents with 28% loss. But the interesting thing here, well, apart from that, that is quite alarming. The other thing, it's that, so this was the changes in flood protection occurred at different locations in the Brigalow belt. So these are different local government areas, and this map shows in blue some regions that actually had an increase in flood protection, driven by an increase in forest cover. So we did have some increase in forest cover in particular areas, although overall we had a decrease. So the important message here is to then understand how for different beneficiaries, these spatial interactions between supply and demand will affect how decreases in ecosystem services will affect different people, and can lead to identifying inequalities and how different people are affected by forest loss or any other drivers of change, and then inform suitable management actions for each beneficiary. So maybe in some areas we would need to restore forest. In some other areas, maybe we want to relocate infrastructure at risk or protect the forest that we've got. So following up on my second chapter and like moving to my third chapter. So I showed before, I found unbalances in how flood forest loss affected beneficiaries. So then my next question here was, okay, now I want to do something to restore flood protection for in the Brigalow belt. So one management objective is that maximize flood protection for the different beneficiaries. And the way we can do this is by restoring, but we have limitations, usually budget constraints. So this is one way of thinking of a management problem. But for this specific chapter, I also wonder, well, what if we not only want to maximize flood protection, but we also want to balance the inequalities that we found. So then the specific question for this chapter is how efficiency, so that means how like the money that we spend, yeah, how much flood protection we get from the same money that we spend. If we change our objectives, if we not only want to get the maximum flood protection that we can, but we also want to make sure that all beneficiaries obtain a similar amount. So that's the question in this chapter. And yeah, I want to make this distinction between equality and equity. So in management ecosystem services, or well, in general, but in this case, like equality would mean providing all the beneficiaries with the same opportunities, or treating everyone the same. But equity would mean considering what is the what's the social background that can lead some beneficiaries to have more access to benefit than others. So to account for this in my chapter, I also considered these this data set developed by the Australian Bureau of Statistics. It's the Index of Socioeconomic Disadvantage. So I accounted for this to then try to identify where are the areas where we would need to prioritize for flood protection that located in those areas where people have a lower socioeconomic opportunities to overcome flood effects or flood damages. So the way in which I then put all this together in a decision problem was to, well, my objective was to maximize flood protection. And that, as I explained before, was the result of quick flow reduction times infrastructure at risk. Then my action was of how I was going to obtain this objective was through restoration, specifically managing brigalow regrowth. So the brigalow has this capacity to regrow from the roots. But we just can't let brigalow regrowth everywhere, or we could, but the brigalow regrowth can only happen where the land has not been intensively managed. So this happens where it's only extensive grazing. But then if we let brigalow regrowth, then that would mean opportunity costs for farmers. So that's our limitation, and that costs money. So this is our problem, and these are the scenarios that I considered. So one scenario, the baseline, in which we could select units, decision units, which are like all these different polygons that you can see. So select units regardless of the beneficiary or the location. An equality scenario where we equally allocated resources among the different beneficiaries that I considered. So the resources available to apply the action were equally distributed among all of them. And then I have another scenario where we also consider this spatial equality. So if we divide the brigalow belts into the different local government areas, in this other scenario, we divided our budget equally for each local government area. So that forced the problem to select at least some mining units in each local government area. And then I had my equity scenarios where I used the socioeconomic index that I described before to then force the selection of units to those where there's highest socioeconomic disadvantage. So main results here. First, just looking at how efficiency decreased when trying to seek equality. So if you see the rectangle here and the square, these two scenarios refer to when we divided the budget equally among beneficiaries. So that meant almost 80% less flood protection than if we didn't care or we didn't split equally the budget. And here, it's the scenarios where we split the budget equally among different local government areas. And we had still a loss, but a bit less, so around 20% for each beneficiary. So this looks like losing a lot. But on the other hand, once we forced the selection of units to be, well, if we don't force that, we, in the baseline scenario, we got some local government areas that didn't obtain any benefit at all, not flood protection benefit at all. And from a management perspective, we don't, it's not ideal to just get some people out of any benefit from management. And these are the results from our equity scenarios. Yeah, So those are represented just like by the differences between the circle and the, I don't know the shape of this. But well, there was not a big difference when we accounted for disadvantage. That's the main point. And in terms of efficiency lost, but we could find for rural communities and urban residents areas with higher socioeconomic disadvantage that our baseline scenario didn't capture. So that's the main message. That efficiency could be compromised, but then would increase equality in that just making sure that different beneficiaries have some level of benefit could increase implementation success, or ensure that resources or benefits will be directed to the areas where are needed the most. And finally, well, I don't know if people are familiar with the RED Plus, but in case not, so RED Plus is this international program that basically, countries from the global north are represented here in green, provide or give countries of the global south money to protect and restore their forests. And they do that to help developing countries achieve the Paris Agreement of maintaining the global temperature below 2 degrees Celsius increase from climate change. So this is an initiative that provide benefits globally. So because we are all experiencing the effects of climate change, so this is something that benefits everyone. However, if you then ask the local communities that are that have to change their management practices to kind of comply with RED Plus, a lot of people are not very happy with it. It can cause lots of different social problems, but also the local benefits from existing services that they used to receive may be at risk. So in this chapter, then I asked the question, what are the trade-offs then between global benefits from carbon storage and local ecosystem services? So for this one, my case study is in the Kaligandaki watershed in Nepal. And I used, well, this was a collaboration with Adrian Bold from the Natural Capital Project, and using information that they collected, and it's represented in this report. So what they did, they assessed carbon storage, landslide prevention, sediment retention, impacting or benefiting a local system, and sediment retention, but benefiting downstream hydropower plant, the Kaligandaki hydropower plant, which is the main hydropower plant actually in Nepal. And they also assessed, they assessed these existing services biophysically, and also the benefit was translated into monetary benefits. So then what I did, I developed a prioritization to identify where to apply different watershed management actions to achieve these different objectives: maximize carbon storage, decrease local sediment that then increase fertility, decrease downstream sediments that then decrease maintenance costs for the hydropower plant, or decrease in annual probability of landslide that then benefited communities at risk. And I have different scenarios to test the trade-offs between these different objectives. The one in which I gave all the weight or the priority to just carbon storage, and I didn't give any weight to my other objectives. another scenario where all of my objectives were given the same weight, and a third one where just some of them, the local ones, were given weight and not carbon storage. So this is what I found. So this is a lot of information, but the important bits. So each different graph is one of the scenarios. And the relevant thing is that in the scenario where all weight is just given to carbon storage, we don't get any benefit to communities at risk from landslides. So we had other scenarios where we also didn't get benefits to all the beneficiaries we wanted. But we found one scenario where we did, and this is the one where that we could balance benefits amongst all the beneficiaries. And the maps here at the top are the locations and the different actions that we would need to apply to achieve a more balanced distribution of benefits. And these are the economic benefits from that balanced solution that we found. So the important thing here is that in our other scenarios, for example, communities at risk of landslide, they wouldn't have any benefit at all. That includes 13 lives saved per year, for example. So the main message here is that trade-offs are inevitable when combining different objectives. But when we acknowledge them and include them, we can generate information, clear information that shows the different trade-offs, and we can negotiate, ideally with all the beneficiaries involved. And in the context of RED+, this international policy framework, that could also be modified to deliver benefits to different people under the same budget. So in summary, identifying different beneficiaries, it's important to identify and address inequalities and inequities in the provision of ecosystem services, inform suitable management actions for them, and promote transparent negotiations of trade-offs. Just to finish, then, so that was my PhD. So now what's next? I am going to start a postdoctoral position with Monique Lin in Laval University in Canada. This is a collaboration as well with this NGO, and I will be doing more spatial prioritization. And this project is also part of this project led by Elena Bennett. So it's just a Canadian-wide project to assess ecosystem services and protect them, basically. So that's it. Thank you so much to my supervisors and Adrian, my collaborator, and thanks to everyone, CBCS.